Hello viewers, in today's lesson we will be discussing about probability density function, which is the second aspect of functions of probability. We started with functions of probability in the last lesson, where we discussed about probability function and its corresponding distributive or cumulative function. So if you are yet to watch the video, kindly make sure you visit the video before coming back to this particular video. So without wasting much of our time, let's move into what we have in this lesson. Probability density function. As I told us in the last lesson that both probability function and probability density function are their corresponding distributive or cumulative function. And we will discuss about the distributive function for probability function. We will also be discussing about the distributive function for probability density function, PDF. It is also known as PDF. It can be shortened as PDF. So the conditions for probability density functions are the random variable x must be continuous. Unlike your probability function, where your random variable x must be discrete, here your random variable x must be continuous. The second condition is that your f of x must be greater than or equals to 0, just like your probability function, where f of x is also greater than or equals to 0. And the third condition is that your integral of f of x from minus infinity to infinity must be equals to 1. Unlike the probability function whereby we using summation, I already told us that the difference between the two is that when you see summation, the first thing that should come to your mind is probability function, and when you see integral, the first thing that should come to your mind is probability density function, PDF. So without wasting much of our time, let's move into an example. But before we move into that example, you can be asked to solve a particular probability with your probability density function. That is, after determining the probability density function, you can be asked to compute a particular probability. So to complete a particular probability with your probability density function, let's say probability of a less than or equals to x less than or equals to b can be computed as the integral from a to b, from the least to the highest, lower limit to higher limit, to integrate from lower limit to higher limit of f of x dx. So that's how you get your probability using the probability density function. Example 1. So this example says the probability density function of the random variable x is given as f of x equals to k exponential minus 3x. For x less than 0, I will have 0 elsewhere, 0 elsewhere. And we also have to find k. Find k, then make k an unknown. So you're going to find k first before using that probability function. And we also have to find the probability, that is, use this probability function to solve the probability of 0.5 less than or equals to x less than or equals to 1. Less than or equals to 1. Solution. So, to determine your k, what can we do? We already have some conditions. We already know that the condition of your PDF is that the integral of f of x from minus infinity to infinity must be equal to 1. So why don't we just integrate these two functions using these conditions and equate the summation to 1? So whereas the integral, recall for PDF, the integral from minus infinity to infinity of f of x dx must be equal to 1. F of x dx, sorry, I didn't include dx here. F of x dx must be equal to 1. So now integrating, you can integrate, here we have x is less than it is x greater than, not x less than. I wrote the wrong question. So for x greater than 0, and we already know that will always be from 0 to infinity. Since it says greater than 0, we don't know where it ends. We don't know if it is 1,000 or 1 million. And this one says elsewhere, that is for conditions, for boundaries where x is not greater than 0. Then that will definitely be from where? From minus infinity to 0. From minus infinity to 0. So here we have from minus infinity to 0, and that will be for 0. The function will be for 0 dx plus, we ended this one at 0, then we started the next one from 0. That's how you integrate. You integrate in boundaries. When you're solving for area bounded by curves, you integrate for each boundaries and you sum everything together. That's the same thing that applies to this aspect. Plus from 0 to infinity, minus infinity to 0, 0 to infinity of k exponential minus 3x dx equals 0. You might have more than 2. You might have more than 2 functions. You might have 3 functions. You might have 4. So you do each functions for each conditions you are given. So it doesn't matter that it is always 2. Everything equals 1, not 0. Everything equals 1. Sorry, we have 1 here. So here we have the integral of 0. You definitely give us 0. So we have 0 plus the integral of this. If you want to integrate k exponential minus 3x, k is a constant, you can bring k out. Then what we have? We have k into, if you integrate exponential minus 3x, you can use a short trick to integrate that. You differentiate the index, which is minus 3x. If you differentiate minus 3x, you are going to have minus 3. Then you divide everything here with that result of differential. So here we have exponential minus 3x over minus 3, because differential of minus 3 is minus 3x is minus 3 over minus 3, but over minus in the denominator can also be brought to the numerator. So you have minus over 3 from where? From 0 to infinity equals 1. So introducing those boundaries, what do we have? 0, you can ignore that. Introducing those boundaries, you can have k into minus exponential minus 3 into infinity over 3 minus, we have minus here before. And when you are introducing value condition, you are going to subtract. So you make sure you put this in a bracket so that you don't mix it up. So minus exponential minus 3 into 0 over 3. Close the bracket and close the bigger bracket because we brought k outside. Everything equals 0. Remember, minus 3 times infinity will definitely give you minus infinity. Then exponential minus infinity is 0. We already know that exponential minus infinity is 0. So automatically everything here will become 0. Similarly here, minus 3 times 0 will give us 0. Minus 3 times 0 will give us 0. And anything raised to power 0 is going to give us 1. So everything here becomes minus 1 over 3. But we have minus here before, minus times minus 1 over 3 will give us 1 over 3. So here becomes k into 0 plus 1 over 3 equals, sorry, this is not equals 0, this equals 1. Equals 1. So then we have what? We have k over 3 equals 1. Then finally, k equals 3. K equals 3. So we are able to get the value of our k. And the next question says to calculate the probability. Calculating the probability of 0.5 less than or equals to x less than or equals to 1. And we have used to determine p from our probability function. So we can write that probability density function PDF f of x. We can write it f of x equals, we already determine p, which is 3 exponential minus 3x for x greater than 0, and we have 0 elsewhere. 0 elsewhere. Then we can easily determine our probability. The probability of 0.5 less than or equals to x less than or equals to 1 will definitely be, you could remember, the integral of a to b. But in this situation, let me write it, integral of a to b f of x dx. And in this situation, your a is 0.5 and your b is what? Is 1. So we have what? Integral of 0.5 to 1 of 3 exponential minus 3x dx. Exponential minus 3x dx. We are neglecting 0 because it doesn't fall within this boundary condition. 0 doesn't fall within this boundary condition. We have 0.5 less than or equals to less than or equals to 1. That only falls within this boundary condition. So that's the reason why we are only doing this in our calculations to determine the probability. So solving this, what we have when we integrate this is a constant. You can break the constant out 3 into, you can have exponential minus 3x over minus 3, just like we differentiated the other one. Then you can have minus, you can bring the minus here, minus exponential minus 3 over 3 from 0.5 to 1. 3 will cancel 3, you will be left with minus exponential minus 3x from 0.5 to 1. From 0.5 to 1. So introducing those boundary conditions, what we have? We have minus exponential minus 3 times 1. You start with upper limit. Minus exponential minus 3 times 2.5. So if you do that very well, you should be having 0.173. If you have 0.173, you can check that, you can press that in your calculator to get the answer to that. So that brings us to the end of our probability density function. Now we're moving to its corresponding cumulative or distributive function. So, just like our distributive function for probability function, your PDA first class is corresponding distributive function, and its corresponding distributive function is given as capital F of x, capital F of x, capital F of x. You know, capital F is used to represent distributive function, while small f is used to represent the function itself. So capital F equals the integral from minus infinity to x f of t dt, f of t dt, where minus infinity is less than x less than infinity. This means we will be having f of t dt, just like your cumulative function for probability function. You know that one is summation f of t. Here it is integral from minus infinity to x f of t dt. Why are we having x here? We are having x because we want the final function to be a function of x. That's why it's x. We want the final function to be a function of x. That is why we are bringing another arbitrary variable t into the expression, so as to prevent confusion or mix-up. And also we can use distributive function under probability density function to compute values of probability as well. Let's say we have to compute the value of a probability of a less than or equals to x less than or equals to b from the distributive function. It's simply the distributive function of b minus the distributive function of a. It is as simple as that. Let's have an example on this. So the example here says find the distributive function which corresponds to the probability density function given by f of x equals to 3 exponential minus 3x for x greater than 0, then 0 elsewhere. Also, use the distribution function to evaluate. You have to use that function generated to evaluate probability of 0.5 less than or equals to x less than or equals to 1 less than or equals to 1. So what do we do? We apply this formula, capital F of x. So in this situation, your capital F of x is going to be integral from minus infinity to x f of t dt. And as you can see from our function, we are not having t, but we want to integrate the x to t. What do? You change those x. You change it to what? You change it to t. You change it to t. Then after introducing your boundary condition, x will return back into the expression. So by integrating, we have from minus infinity to here to 0. Minus infinity to 0, 0 elsewhere. Then you have x greater than 0, and that will definitely be what? 0 to x. In this situation, it won't be 0 to infinity. Unlike the first case, here it will be 0 to x, because our formula is not from minus infinity to infinity. Our formula is from minus infinity to x, and in this situation, x serves as the maximum value. You know, infinity simply implies your maximum number. So here we have what? We have 0 dt. We are having dt because we want to integrate with respect to what? With respect to t. Plus the integral from where? From 0 to x. From 0 to x f of t. This will definitely become 3 exponential minus 3t. 3 exponential minus 3t dt. 3 exponential minus 3t dt. So this will automatically become 0. This will automatically become 0. So you can bring 3 out because it's a constant 3. So here we have integral of this. We have done something related to this before. So we have minus exponential minus 3t over 3. I already told us how we arrive at that. You will differentiate the index which will give you -3, and you divide it by everything there. You divide it by use it to divide exponential -3t. And you know, minus can come to this side and it becomes minus exponential -3t over 3, and we introduce a boundary condition from where? From 0 to x. So we can see 3 will cancel 3 automatically. We'll be left with what? Minus exponential -3t minus exponential -3t from 0 to x. So introducing the boundary condition, we finally have minus exponential 3x minus exponential -3 into 0. Because we have minus here before, and it becomes minus. So we have what? Here we have -3 minus exponential 3x. This becomes exponential -3 times 0. -3 times 0 gives us 0. Anything per 0 becomes what? 1. So automatically here is 1, but we have minus here, it becomes -1. And minus is also outside here. Minus like minus becomes plus. So we have everything to be what? To be +1. Everything to be what? To be +1. We have everything to be +1. So finally we can write it as 1 minus exponential 3x. We can write it as 1 minus exponential 3x. So that's automatically our distributive function. But don't forget, we have to use that distributive function to calculate the probability. And that probability is from 0.5 less than or equals to x less than or equals to 1. 0.5 less than or equals to x less than or equals to 1. And that automatically gives us what? F of b minus f of a. And in this situation, your b is what? Your b is 1 and your a is what? 4.5. So that automatically means f of 1 minus f of 0.5. What does this mean? You simply input 1 and 0.5 into your formula of cumulative function. So we have what we have? We have 1 minus exponential 3 into 1. Because here x is 1 there, minus 1 minus exponential 3 into 0.5. Exponential 3 into 0.5. And if you do that very well, you should be having 0.173, just like the previous example we've done earlier. So the probability will give the same answer, but with different methods. So that's the second example. That's the example to cumulative function under probability density function, which happens to be the second example of this lesson. So let's be taking the last example. To wrap it up. So this example says find C such that f of x is a PDF, that is probability density function, hence obtain capital F of x. Obtain capital F of x. So we are given the function. But a number was removed and replaced with an unknown. So we have to calculate that unknown C. F of x squared plus cx 0 for 0 less than x less than 1, for 0 less than x less than 1, and 0 elsewhere. 0 elsewhere. So we are firstly asked to find the value of c. So how do we do that? We have done a similar example, just like the approach we used in the first example relating to this. You apply the condition, that is the condition that the integral of f of x from minus infinity to infinity equals to 1. So recall that the integral of minus infinity to infinity of f of x dx equals what? Equals 1. So we can easily compute that. Here we have the integral. So automatically we have the integral of minus infinity to 0, since we have what? S squared minus infinity to 0 dx plus the next one. You start it from 0 because this one ends at 0 to, here it will be 0 to infinity, it will be 0 to 1, because this is from 0 less than x less than 1, unlike the other one that is x greater than infinity. Here we are limited to what? To 1 and not to infinity. So that would be 0 less than x less than 1. So automatically we are integrating this one from 0 to here, 0 to 1, s squared plus cx dx, everything equals 1. Automatically this gives us what? 0, integral of 0 plus the integral of this will give us, when you want to integrate a variable x, what do? You definitely add 1 to the exponent. For example, let's say you want to integrate f raised to power n dx, it will definitely be equals to f raised to power n plus 1 over n plus 1. So that's how we do about that. So automatically this will give us what? S raised to power 2 plus 1, which is what? 3 over what? Over 3 plus this is a constant, so it doesn't affect, you don't touch it. So here we have what? C x raised to power 1 initially, then it become x raised to power 1 plus 1, and that's x raised to power 2 over what? Over 2, and everything from where? From 0 to 1, everything equals 1. So we can now introduce our boundary condition. If you introduce 1 to this, we have what? 1 raised to power 3, which is 1 over 3, plus if you introduce 1 into this as well, 1 as 1 square, it becomes c over 2 plus c over 2 minus 0. When you introduce 0, it was 0 over 3 plus 0 over 3 equals 1. Everything equals 1. So automatically this becomes what? 1 over 3 plus c over 2. Then this becomes what? Everything becomes 0. 0 over anything is 0. Everything equals 1. So we have c over 2 to be equal to 1 minus 1 over 3. So if we take the LCM of this, we have what? We have 3. 1 and 3, we have 3 times 1, that's 3. 3 and 3, 1, so this becomes minus 1. So this gives us what? 2 over 3. So automatically c over 2 equals 2 over 3. So we can make c, the formula. What do we have? We have c to be equals to, if 2 goes to this side, it becomes 2 times 2. Automatically c equals 4 over 3. C equals 4 over 3. So we are going to determine C. What else are we asked to calculate? We are asked to obtain capital F of x, and capital F of x is automatically a distributive function. So to determine your capital F of x, firstly we write your probability density function, which is what? Which is going to be what? Which is going to be x squared plus 4 over 3. We have replaced C with what? 4 over 3 x. For 0 less than x less than 1, and we have 0 elsewhere. And if you can't find elsewhere here, another word that can be used is otherwise. Another word that can be used is otherwise. Please take notes. Anytime you find otherwise there instead of elsewhere, we are still on track. So here we have the probability density function. So we want to determine the probability. We want to determine the distributive function. That is your capital F of x. And we know that capital F of x is the integral from where? From minus infinity to x. Sorry, to x of f of t dt, of f of t dt. So everywhere you find x in your formula or in your function, you replace it with what? With t. Then when you use the boundary condition, x comes back into the expression. So here we have what? From when we integrate from minus infinity to 0, integrating from minus infinity to 0, that will be 0 dt. Don't forget, we are integrating 0 to t. Plus, here we have from 0 to, we have 0 to x from this formula, from our formula from 0 to x of t squared. We will replace everything in the function with t squared plus 4 over 3t plus 4 over 3t dt t squared plus 4 over 3t dt. Then we integrate. So if you integrate this, you have 0. You integrate that, you have 0 plus if you integrate this, what do you have? T squared. It becomes t cubed over 3, that is 2 plus 1, 3 over 3, plus this becomes t squared. So that automatically becomes 4 over 3 times t over 2. Then 3 times 2 becomes 6. So here we have 4t squared over 6. 4t squared over 6, which can be broken down into 2 over 3. This can be broken down into 2 over 3. So here we have from where? From 0 to x, which is our final position. Then we can finally write this as t cubed over 3 plus 2 over 3t squared. From where? From 0 to x. Then using our boundary condition, we have s cubed over 3 plus 2s squared over 3 minus 0 cubed, we have 0 cubed minus 0 cubed over 3 plus 2 times 0 squared over 3. So automatically everything here becomes 0. So we finally have our capital F of x. Our capital F of x to be what? To be s cubed over 3 plus 2s squared over 3 plus 2s squared over 3. But 1 over 3 is common. We can bring out 1 over 3 and have it as 1 over 3 into s cubed plus 2s squared into s cubed plus 2s squared. And that's the final answer to that. That's the final answer to that. So that will bring us to the end of this lesson. So in the next lesson, we will be moving to some other aspects of probability, special probability function, special cases of probability. So if you are new to this channel, kindly make sure you subscribe, you like, and you share the video to those that will find it helpful. Tutor Bosun is here. Thank you.